So 2.5, we're going to be writing a function rule. Basically, it's word problems. We're going to take a word problem, and then we are going to translate it into an equation, and that's part 1. So we're just going to practice that a little bit. Then we are going to actually evaluate them in part 2. Okay, so right now we are just taking a word problem and translating it into an equation. Okay? Problem 1 says, you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature, and I'm going to underline this because this is where my equation is going to come from. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? The first thing that you need to do in all of these problems is define your variables. So the things that are unknown in this problem, the outdoor temperature, so let's call it T. So T is going to be the temp. And then the other unknown is the number of chirps that the cricket makes. So I'm going to call that N. On your homework, on your quizzes, on your tests, this is showing your work. You have to tell me what the variables mean. If you just plug variables into your equation and you don't tell me what they mean, I don't know what the letters stand for. So you have to identify your variables. So then we're going to write an equation out this. The outdoor temperature is, what does is mean, guys? Equal. So that's going to be T equals about 40 degrees more than. So that's going to be 40 plus 1/4 the number of chirps, 1/4 N. That's your equation. All we are doing in this problem, or for this part, is translating from a word problem into an equation. That's all we are doing. Make sense? Easy? Okay, so let's look at page 129. And now we're going to look at problem 1 in your book, 129. So here's the problem. A landfill has 50,000 tons of waste in it. Each month it accumulates, so I'm going to underline that because that's what we're starting with. Each month it accumulates an average of 420 more tons of waste. What is a function rule that represents the total amount of waste after M months? So the first thing we need to do is come up with our variable. The first variable they give to us is M, and that's the number of months. So let's identify that. M equals number of months. What would our other variable represent? The total amount of waste. What do you guys want to call that? T? Okay, so T equals total waste. If you want to use W, you can use W. If you want to use Y, you can use Y. You can use whatever variable you want. There's not a right or wrong answer. You just have to tell me what it stands for. So that way I know. Okay, guys, so then how would we do this? T is what we're solving for, right? So T equals, so let's read what this says. We accumulate 420 more tons each month, but how much did we start with? 50,000. So how would we write that as an equation? 50,000 plus 420. T is our total waste. M. And that's your equation. 5,000, 50,000. Thank you. No, you have to put 5,000. Do not put 50K. So let's break this down, guys. Every equation basically has an initial value and a rate. What is the rate that our waste is growing? 420. So label that rate for me because this is going to come in handy in the next unit. And the 50,000 stands for what? How much we started with. We call that the initial amount. Okay, so our initial amount was 50,000. Even if no waste accumulates before we even start measuring, we automatically start with 50,000. Does that make sense? Okay, so here's what I want you guys to do. Practice this on your own. Do problem number 1, and then when you turn the page, do problem number 2 as well. Okay, so do problems number 1 and 2 right now on your own, or you can work with your partner. So number 1. A worker's earnings, E, are a function of the number of hours, N, worked at a rate of 8.75 per hour. Here's how you should have started. E equals total earnings. Or you could have just written earnings. Earnings. And N equals number of hours worked. Okay, so that's how you should have started. If you do not, it is not showing your work. You need to make sure that you show all of your work. So then how do I write this as an equation? What did you get? Who's in 36? No, Pecan, what did you get? E equals 8.75N. Is that what you guys got? Yeah. Good. So, question, a couple questions. What is 8.75? Is that an initial value or is that our rate? That's our rate. Why don't we have an initial value? Do you get paid if you don't work? No. Or at least not in this problem. Okay? So that's why we don't have an initial value. Now I want to point out something to you guys with the language. Notice how it says a worker's earnings E are a function of the number of hours N. So there's going to be a question like this on your homework where it asks you which one is the independent and which one is the dependent variable. So if E is a function of the number N, is E going to be your dependent variable or your independent variable? E is the dependent because that's what
they're a function of.
It comes as a result of what you plug in for N, right? That's what it means. So when it says E is a function of, that means that the answer has to do with whatever you plug in for N. So N would be then our independent variable, okay? So just so you guys know, it might be a good idea to label E as dependent, N as the independent, because there will be a question like that on your homework where it just asks you to identify which one's which, okay? Good. Okay, so then number 2, baking. Yes. I have no idea. The almond extract. So almond extract is exactly like vanilla extract except made from almonds. An almond extract A remaining in an 8-ounce bottle decreases by 1.6 for each batch B of waffle cookies made. So we do know that A is the amount of extract. And then B is the number of batches, so batches of cookies. Okay, so batches of waffle cookies. Or I'm just going to put batches of cookies. Okay, so that's what you should have put. If for A, you wrote down amount of extract remaining, that's even better. B, if you put batches of waffle cookies, that's even better too. Okay, but the total amount left and the total amount remaining and the total amount in the bottle, it's all the same. Okay, so guys, we're going to build this one together. What am I setting everything equal to? Which one is the dependent variable? Who's 14? Bisman, what is our dependent variable? What do we set everything equal to? The dependent. Okay, so we start with A equals, right? Okay. All right, guys, what's the initial value in the bottle? How much do we start with? 8 ounces. So I have to put that in front, right? So that's like when my bottle is whole, it has 8 ounces in it. So then if I am decreasing by 1/6 ounces for each batch, what am I going to be doing? Minus 1/6 B. There is your equation. Okay? If you wrote A equals 1/6 B minus 8, is that the same thing? No. No, because the order matters here, and you have to start with how much extract you started with. Does that make sense? Okay. How many of you got both of these right? Easy so far, right? Yeah. Okay. So what we're going to do next is we are going to take a problem and translate it into an equation. But then I'm going to give you a value to plug in, and we're going to figure out how much of the dependent variable we end up after we plug in something for our independent variable. So let's look at the next example. So you guys are not doing this one with me. This one is just the Mrs. Dodson show. Okay. So, yeah, it's like the best show ever. Okay. Yep. Okay, so concert revenue. A concert seating plan is shown below. So here's our concert seating. In the front, we have reserved seating. It costs $25 a seat, and there are 10 rows and 12 seats in each row. Remember, with reserved, that's like you have to buy the tickets ahead of time, right? Okay. In the back is our general seating, so that would be like some tickets sold ahead of time and then whatever you buy at the door. There are 30 rows with 16 seats per row, and there's $10 for each seat. So the reserved seating is sold out. So we have sold all the reserved seating. We already know that for our reserved seating, we've sold all those tickets. The total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. And then after we write our function rule, we are going to figure out what the maximum possible total revenue is. So how do we figure this out? Let's let R equal our total revenue. Revenue is like how much money you make. And then we need to figure out, all of this is based on how many general seating tickets that we sell. I'm going to call that N. So N is going to be the number of general tickets sold. Okay. So then let's write an equation for this. That's R equals. We already know that we sold out all the reserved seats. So can I figure out how much money we made from the reserved seating? 10 times 12 gives me how many total reserved seats there are, and then if they're $25 each, what would I do? Times 25. Plus, how much we make on each general ticket sold. So general tickets are $10 each, and depending on how many we sell, we multiply that by N. This is not completely simplified. We can actually do the 10 times 12 times 100, or times 25. So 10 times 12 gives me 120, times 25 gives me a total of 3,000, plus 10N. There's your equation. Okay? So that is we know for sure that we made $3,000 already because we sold all those reserved seats. And then we just add 10 times however many general seating tickets that we sold. Make sense? Okay, so then I want to know what is the maximum possible revenue. How can we figure out the maximum possible revenue?
You just add all the money you got from the general seating and the reserve.
Yeah, so we add up all the money from the reserve and the general, but how do we figure out how many general seats there are? 30 times 16, so that's what we're going to plug in. So the max number of seats there are 30 times 16, which gives me 480 total general seats. So that means that we sold out the whole place. Okay? So here's how I want you to show your work. That means for N, we are going to plug in 480. So I want you to write on, when you do these problems, N equals 480. And then I want you to show your work. R equals 3,000 plus 10 times 480. So you are showing me the equation and what you plugged in for N. Then I want you to follow order of operations. So you're going to multiply 10 times 480, which is 4,800. And then last, you can add the two numbers together. Now, if this is revenue, what do we have to put? Dollars. Does the dollar sign go in front or behind? In front. And all of this comes out to $7,800. Okay, so that is how I want you to show your work. You tell me what you're plugging in. You show me that you plug it in, and then you show me all of the steps involved. Okay? It is not a lot. It is 3 lines. So let's do problem 2 now from your book. So let's look at your book. Problem 2. A kennel charges $15 per day to board a dog. So I'm going to underline that, $15 per day. Upon arrival, each dog must have a flea bath that costs $12. So it doesn't matter if you are keeping your dog there for 1 day or for 20 days. You're still going to pay $12 to give him a flea bath. Write a function rule for the total cost of N days of boarding plus a bath. How much does a 10-day stay cost? So our variables, they give us 1, N, equals number of days. What's the other variable? Total cost. What do you guys want to give that one? T or C?
T.
Let's do C this time. If you want to do T, do T. So C equals the total cost. Okay. So guys, how would, what would be the first part of my equation? Who's in number 10? Chewy. What would be the first part of my equation? How would we start it?
N equals?
N equals?
C equals.
C equals what, guys? What are you paying no matter what or no matter how many days? Who's in 27? Maddie, what are you paying no matter what? $12. And then what, guys? Plus, what's the rate? 15N. So there's your equation. Okay, C equals 12 plus 15N. Then the question is, how much does a 10-day stay cost? Where am I going to plug in 10? N. So I need you to write it. N equals 10. And then you need to write it in this way, and on your homework you need to write it this way, and on your tests and quizzes you need to write it this way. C equals 12 plus 15 times 10. So you're showing me what you plugged in for N. And then we start evaluating. C equals 12 plus 15 times 10? 150. And so then your total cost is what? $162. Okay, and then box that also. So this is how I want you to show your work. Everybody got it? Okay, question, just out of curiosity, let's see. Does a 5-day stay cost half as much as a 10-day stay? Explain why. How many of you guys think a 5-day stay will be exactly the same, or half of the 10-day stay? Who thinks it will not be half of the 10-day stay? Why? Brianna, why? Yeah, let's do the work and let's see what happens. So if N equals 5, that C equals 12 plus 15 times 5. What's 15 times 5?
75.
Okay, and then 12 plus 75 gives me $87. Is 87 half of 162? No. Half of 162 is 81. But what did you notice? If the cost for just the days was 150 and 10, is 75 half of 150? Yeah, so cutting the number of days in half cut the total cost for the days in half, but not the $12, so not the cost of the bath. So let's write that in words. Okay, so how do we want to start this? So first, no. Making the stay shorter. Only halved what? Yeah. Only halves the daily charge. But we also had to pay for the bath, right? So not the bath charge. Okay. So halving the number of days that you stay, half how much you pay for all the days, but you still have to include that $12 for the bath. Okay? All right, so here's what I want you guys to do. You can work by yourself. You can work with your neighbor. I want you to do number 3, aviation, and number 4, diving. Okay? So do numbers 3 and 4 for me now. I'll leave problem 2 up. Number 3 says that a helicopter hovers 40 feet above the ground. So that means that it's not going any lower than 40 feet. That's its starting position. Then the helicopter climbs at a rate of 21 feet per second. Write a rule that represents the helicopter's height above the ground as a function of time. What is the height after 45 seconds? So you should have put h equals the height of the helicopter, t equals time. Your equation should have been h equals 40 plus 21t. How many of you guys got that correct? Awesome. Now, before you plugged in 45 seconds, how many of you guys double-checked to make sure that our rate also had seconds in it? Anybody?
I did.
Because what if it had asked us what was the height after 1 minute? What would you have had to do?
Multiply 45 times 60.
Convert it into seconds. So what would we have actually plugged in? 60. Because the rate is in feet per second. Does that make sense? So you have to make sure that your units are matching up. In this case, it does. So here's how you should have shown your work. H equals 40 plus 21 times 45. 21 times 45 is 945. And then you can add 40, so you should have got 985 feet. Make sure you put feet at the end of it. How many of you got this one correct? Awesome. Everybody good so far?
Yeah.
Okay, the next one was the tricky one, so let's look at number 4. Number 4 says, a team of divers assembles at an elevation of negative 10 feet relative to the surface of the water. So when we're talking about feet or altitude in terms of like ocean level, anything below the water is in the negative range. So negative 10 feet means that they've met 10 feet below the surface of the water, okay? Then the team dives at a rate of negative 50 feet per minute. Write a rule that represents the depth d as a function of time t. What is the team's depth after 3 minutes? So d was the depth, t is the time. Your equation should have been d equals negative 10 minus 50t. How many of you guys got that? Awesome. Why is the rate negative? We're going further and further down, right? Okay, so then we plug in t equals 3 because we're going down at a rate of 50 feet per minute and 3 is in minutes, so we're good there. So d equals negative 10 minus 50 times 3. D equals negative 10 minus 150, which gives us a total of negative 160 feet. Is it okay that my answer came out negative? Yes, it has to be because we're below the surface. If you wrote your answer as 160 feet below the surface, I also would have accepted that. Okay? But negative 160 is actually a little bit more precise. Okay?